Pleasure. How are you?
Yeah, thanks.
Hi, everyone. This is a great venue. We're at the last panel of the day, so we have a high bar and great panelists here to make it a very interesting conversation. And then, what is there? Happy hour, all sorts of fun things after. So we'll dive right in. I'm Dayna. I'm the founder of a fund called Construct Capital. We invest in advanced manufacturing, supply chain, and other surrounding software. And as you can imagine, connected hardware companies. In my past life, I was a proud investor in companies like Formlabs and Tulip. So great to be back here today. But literally enough about me, because we have really an all-star panel here with Mike, John, and I call you Secretary Hal now?
You can call me
Okay.
whatever you want. Fine.
Yvonne here, who I've also known for many years, all of you, great to meet you, Miles. So the topic of our panel today is about how are the forces of industry and particularly policy converging, but everyone on this panel has a deep background in bringing new innovation to market, and now with Yvonne's new role as the Secretary of the Executive Office of Economic Development, I'm so proud of myself for getting that right, can kind of give us a view of the policy side, especially in Massachusetts. But why don't we start, Miles, with you, because I think Miles has an interesting, not only background, but in his current role at Rebuild, and you can tell us a little bit about it, he's bringing more mature companies together, but actually innovating on the advanced technology side and automation and manufacturing. And so we've got perspective of startups, we've got perspective of policy, but kind of where technology meets existing industry and how to modernize that advanced technology is the perspective that I thought we'd start with, kind of right in the middle.
Sure. I'm sure, is there a question there? Or?
The question is, what have you seen in terms of how do you bring advanced technology to established manufacturing processes? How does it get integrated? What's the ROI to it? Is there advantage? Is there not?
Sure.
Is it better than the status quo?
I think it's an interesting question because I think in America we look for big step function change type improvements. So we love technology. We love the idea that we can invent something new that will move a situation forward a lot. It's why we like drugs to solve diabetes instead of changing our diet, right? And in manufacturing, I think, and a lot of the engineering related to it, there's a lot of need for incrementalism. And unfortunately, our experience, and we have, I think, 11 plants now across the country, is that a lot of the technical solutions that are on offer require or expect us to make changes that are not possible on a day-to-day basis. And they're focused largely on driving decision-making off the floor and up towards management or towards senior management versus enabling what we think is the key to technical and manufacturing advance in this country, which is lean or continuous improvement through respect for people, which means using technology to drive decision-making down as far as we can. And the challenge we have is that it's very hard to get people that want to work in manufacturing and or are educated to work in manufacturing. And so we need tools that will help them to be, the people we do have, to be more effective, and that will help people come up to speed more rapidly. So we don't need tools to monitor the processes and report that to someone's desk. What we need are tools that let people that are in a process continuously improve that process 0.25% a week so that over years we increase our competitiveness. And that is what I'd like to see, but what we tend to see are these very packaged solutions that promise some 28% improvement in our productivity next week, and that just never happens.
It doesn't happen overnight, for sure. No. Maybe over years and a decade.
If you're lucky.
If you're lucky.
Yeah.
And I want to come back to that, especially your point around the workers, but I want to kind of go down the panel and hear other perspectives, but I do want to come back to the worker shortage and augmenting workers today. Talking about the improvements that new technology can have. John is a repeat entrepreneur, he's an innovator, he's at MIT as his day job, but doing all of these other things on the side and bringing a lot of new commercial development to manufacturing and advanced technology. Can you give us some perspective of how those changes do get realized over what period of time, and how you square the research with new commercialization and some of those improvements? What's on the ground floor of new development that has those promises long term?
Yeah, well, being fortunate to sit at MIT most of the time, we of course get to see all the new things that our students and our faculty are thinking about. And I really resonate with Miles' point that we also need the technologies that can make on-the-ground improvements and prove their value over time, rather than being a sort of breakthrough that's dropped on the factory floor, requires the construction of an entirely new system around it, because maybe that is the ideal end state, but the ability to get there is quite tortuous and lengthy. I mean, having worked very closely in the 3D printing additive manufacturing space over the past decade, I think that's maybe a very suitable example where most of the technologies were invented 30, 40 years ago, and perhaps they were before their time in terms of the requirements for materials, software, and hardware, but only now, and maybe still in the future, do we see the high-value use cases emerge that generate enough traction so a technology can go from trying to be an everything solution to focusing down on specific examples where you can create value, and then the return can go and be reinvested in the future development of the technology. And I'm also really excited about that when we speak to additive as a technology and the supporting aspects of the ecosystem, the realization of new products based on these new manufacturing technologies. And I think when we start to see new differentiated products that emerge as a result of more advanced manufacturing, including that domestically, it'll really indicate an important transition.
Mm-hmm. Mm-hmm. We'll also come back to the talent equation, because John's new role is head of, is department chair of mechanical engineering. So he sees the talent coming up and the interest every day in some of these sectors, and thanks for the perspective on some of the additive manufacturing technologies you've been involved in. And so now Yvonne, who has had a successful career in startups, investing, advising, and now kind of squaring both of those. And if there's any big belief in how Massachusetts will continue, but also excel in becoming a powerhouse of economic development around some of these advanced technologies that you see in the room today, I have no better person to put my faith in than Yvonne. But tell us, what are the challenges you're particularly tackling? What attracted you to this new role, especially in light of some of the things we've just heard?
Yeah, no, well, first of all, huge thanks to Formlabs and Tulip and Autodesk for organizing this, and for all of you for being here. This is near and dear to my heart. What people probably don't know about my background is I started my career actually doing a lot of work with manufacturing plants. So I've spent time in all kinds of plants in Mexico, all over the US, in Canada, all over Asia, in Europe, and nothing makes me more happy than actually seeing stuff getting made of all kinds. So this is my happy place. And then huge thanks, Miles and John. I got to go visit, and I got to see his factory. It was one of the coolest days of my job. And Dayna, thanks so much for coming up for DC and for doing all the work you're doing at Construct. So I have had a whole career in business up until now. So I've been in large companies, public companies. I've been in startups like PillPack, which we sold to Amazon. I've been a CEO, a CFO, a COO, an investor, and also a board member. So lots of experience in business. And it was very unexpected, actually. I had dinner with you in December, in early December, had no idea I was going to be in this role. And then the week before Christmas, I got this call on my cell phone from a number I didn't recognize, thought it was my kid's doctor, picked up the phone, and it was Maura Healy. And she said, yeah, I'm taking office soon, and I'm looking for folks to join my team, and I want someone with business experience. And a week and a half later, I got this offer. And so it's been a very fascinating almost 8 months in state government. I'm learning a ton and feel very honored and grateful to be in this role. And there are tons of opportunities. This is a very interesting time in the world and in the country, and in particular for our state. So in Massachusetts, we already are a leader in so many ways. We're so lucky to have awesome folks like you all, and MIT and Harvard and BU and Northeastern and UMass system and all of the great K through 12 education. We have awesome talent and a great ecosystem, and we have such leading companies. Large companies, big manufacturers, Raytheon, Analog Devices, Applied Materials, a history of robotics, Boston Dynamics, iRobot, Kiva Systems, and then tons and tons of startups here, including VulcanForms. So we're very lucky in our state. The question, though, is technology is changing, the world is changing. What can we do together to make sure that we lengthen our lead and that we solve the bigger problems that the country and the world need to be solved? And I was actually just before this at an AI conference talking about AI, and actually I think these two conferences should probably just combine, because AI, I think, is going to be the most powerful in many ways when it's embedded in manufacturing and in hardware and in robotics. There's so much opportunity here. So in our state, we're right now working on our economic development plan, trying to figure out over the next 4 years, 10 years, what are the things we can do as a state? We're not going to meddle in markets, we're not going to, pick technologies, but what are the things we can do around convening across the ecosystem, around investing our resources and our incentives and R&D grants, around changing regulation as needed, around using our state power to try to use our own purchasing power to lead, and then also around messaging. How can we get the message out around people adopting all of these technologies faster? So that's what really we're working on now, and we're really lucky also that we have a great set of quasis that work with us, including Mass Talent, and I think we have Ben and Farhad from Mass Tech. And they work on a bunch of things, including Mass Talent, which is around getting the right workforce and also going after a lot of federal opportunities like chips and science. So a ton of opportunity for us here, and very excited and honored to be able to work on it.
Yeah, that's great. I mean, it is, it's such an interesting time. And the Autodesk keynote this morning, they talked about how the past, 5-10 years has been about digital transformation. I was really happy to hear that we maybe can put that word to bed in favor of generative AI or AI related to manufacturing, and we're at very early innings. I like the idea of combining. There's just sort of so much data in this space that has yet to be unlocked or realized, and what we can do with it. But that's sort of the next 10 years. Well, let's talk about today. Miles, can you tell us a bit, again, I like your perspective of sort of grounding us into sort of what is today and what is happening, because you have these larger companies that you are automating and bringing advanced manufacturing to. Tell us, just give us a sense of the day-to-day of some examples of what have worked, what is working, and what, maybe it's the workers, maybe it's the talent, maybe it's a little bit of just moderate improvement that kind of, for lack of a better phrase, keeps you up at night in terms of if I could just unblock that one thing, it could go from 1% to 5% improvement anyway.
So from a technology perspective specifically,
technology perspective, people, it could be anything. It could be training, it could be
sure.
What is the biggest blocker?
I already spoke to the sort of availability of talented people that want to be or can be in manufacturing is super important. And one of the things I'm concerned about in terms of a lot of the technology push is about labor elimination. When there is so much more productivity to gain out of the people that we have, I want to make sure that we focus on that. So a couple of areas, we invest pretty heavily ourselves in our own digital threads internally. So where we're trying to do is automate the process by which a customer wants something, we can design it, we can bring it to our floor, we can get that out, we can track all of that. You'd be amazed, one of the real challenges is a lot of smaller to mid-sized manufacturers, of which we are kind of a group of, they are very, underdeveloped in that area, right? So yes, they have MRP and they have ERP, but they have paper travelers everywhere. They have manual quoting processes, and they don't have the bandwidth or the personnel to bring that to the next level. And there's a lot of cost there. So we spend a lot of time and energy on that. I think that's an area there's a lot of opportunity. Of course, there's opportunities in processes as well, whether it's new kinds of additive manufacturing and the like, but those tend to have a bit more of a gestation period, right, to be fully adopted in the environment. So we work on those things, but I think of those as a little bit more of a background opportunity. They take longer. There's a lot of interest, of course, in robotics and automation. From our perspective, we tend to find that on average, it's a lot easier to improve the productivity of the people we have than to automate them out. And so we tend to try to err that way because, to the point made, if a state like Massachusetts or any part of our country wants to drive manufacturing, it should be about creating more employment opportunities while being profitable, as opposed to, we could all make a lights out factory next week, be very capital intensive. I don't think the return would be that great, but why would we do that? What's the point of that?
Can I just say, so this is something that we talked about a lot when I was at PillPack. So we were an online pharmacy, so we took medications and tried to pre-pack them. And you can do it through human labor, but it's a pretty monotonous job. All the pills look the same, they're the same size, it's very easy to make errors. We ended up putting in a lot of automation and robotics. And the conversation we had with our team, because nobody likes change and everyone's worried, what does this mean for us, is that there's certain things that robots and AI and machine learning are going to be way better at. And by the way, a lot of those things are very boring and monotonous. But if we use robotics and technology to do those things, it frees up human time to do the way more complex things, where you have, all kinds of problem solving. You need empathy. You need to get different parties together to troubleshoot something. And so we actually scaled and grew much faster, applying technology and actually increasing employment at the same time, creating way better service.
Yes, that's true in principle, but the reality is a lot of those people that get eliminated by those robots are not getting those other jobs. So
you have to be intentional, I think, about how
many manufacturing environments, we're trying to take out actually skilled people instead of harnessing those people to actually do what you said, which I agree 100%, which is use their knowledge to engage creatively to make the process work better. So the problem, I think, a little bit is, I think we'll all violently agree that when we talk about technology in broad strokes, right? That's not enough. You have to get into the detail. How are you going to apply it? What's really going to be its specific impact? And we often like to speak in these very broad kind of things like robotics, automation, fantastic. And there's a lot of nuance and every situation is different. We have to evaluate that. So to your point, someone working in a warehouse may be picking a pill and putting it in a package. That is pretty mundane work. I'm not sure that's that great or enjoyable, but we also are trying to automate people that run machine tools or program them or run high, quality inspection processes, and those are skilled jobs, those are meaningful jobs.
I was just going to say that. So the other thing that we've been spending a lot of time thinking about in my new role at the state is when we say manufacturing, that means a lot of things. And in Massachusetts in particular, there's certain parts of manufacturing that we're just not going to be good at, where you need super cheap, commoditized labor, very monotonous, you need cheap energy, you're doing very kind of simple things, and there's a lot of turnover. That's not really us. The place where we have a big advantage and a big opportunity, where we have a right to win, is these amazing startups that are coming out of our universities that are doing groundbreaking work on climate tech, on decarbonizing, on life sciences and biomanufacturing, on thinking through advanced defense systems. And those places are where, as you get out of lab and you have to scale and you have to manufacture, you need a skilled workforce that really understands processes and systems. You don't have to have a college degree. You can have a great career, high paying, but you need to have a skilled workforce, and it needs to be you need to be proximate with the engineers to to kind of problem solve and to prototype and demo things. And so that's a lot of what we're focusing on in Massachusetts with this program called Mass Talent. How do we link our labs and our patents and our R&D to actually scaling up in this advanced manufacturing type of world?
And you mentioned, first of all, great points, and sort of like how do you invest in the next 10 years of talent and whatnot. And you mentioned, how do you get the talent to program? You mentioned the word program. So I want to come back to where does software, when you think about a mechanical engineering department now, where is software in all this? I'm sure it's a huge piece. The future of work in these environments is not just picking, packing, doing one thing, pushing a counter button and passing it on to the next. It's more integrated. If we're going to use our comparative advantage as a nation, frankly, we have to bring these jobs into the modern era, make them advanced technology jobs to attract the right talent. Where does software come into mechanical engineering these days?
Software and modeling and simulation AI tools are transformative in education, and that's a much broader conversation of how we learn and how we digest information and search for information. At MIT, we're trying to balance the two. First, recognize how these tools can augment how we teach students and the kinds of problems that our students can solve in courses and the things they can design and fabricate. On the flip side, we still have to teach the fundamentals. Right? Yeah. Just like thinking of advanced technology augmenting human productivity without learning the kind of old school fundamentals in the first place, I would bet that you fundamentally change how you think about problems, and you may miss the elegant solutions, the only things that humans can do best, maybe at some point in the future. And one of my colleagues, Professor Ellie Sachs, who actually invented binder jetting at MIT back 30 plus years ago, so as the connection to the theme of this conference, his top priority now as a professor at MIT is a method of learning he calls guided discovery. And it's basically an experiment you do in class, and this started in our introductory mechanics class where you learn about how beams bend and twist. But you sit down with an experimental kit and you step through a series of questions that asks you to basically discover the physical phenomenon that you would have learned about in the textbook and lecture. And then you go to the lecture the day after or the next Monday and you're taught the theory. And it's really changed how students approach these topics from a hands-on basis from the early stage.
Yeah, it is so much to do with the talent of invention and also the talent of implementation. And like you said, there is no, Miles, like you said, there is no sort of, and I think everyone in this room, given that they're largely practitioners, know this too, there is no magic robotic solution, complete automation, lights out facility that you can implement tomorrow, or else we would all be, doing other things while that's happening. So how do you think about robotic solutions and kind of retraining workers? When do you embrace? When do you run away? What are, when you're on the ground kind of deciding implement or not implement something, can you give us a success story and a absolutely not?
Yeah, so we use a lot of robotics, particularly in areas where safety is a principal concern. So we have a set of principles, the Rebuild Way. It's 16 principles we guide our business with. The first is safety. So whenever we can use a piece of automation to avoid a situation that could lead to someone getting hurt, like taking materials out of a furnace, right, or out of a very large press, we tend to use automation. But we try to make sure that it's used in a way that's augmenting a person. So again, I can't emphasize enough this need for continuous improvement. So you had Jim Womack here earlier, right? He's sort of driven a lot of this over many years. We tend to really underestimate the benefit of small, ongoing changes driven by people at the floor and all the way throughout the organization, everywhere. Accounts payable clerk, to an operator, to everybody. And so we try to use automation in an augmenting way, not a replacing way. What's interesting though, I find is there's a lot of developments today around cobots and new kinds of automation. We tend to find them pretty expensive. There's sort of this interesting phenomena going on now where you can buy used automotive robots, like big Moto Man robots that have been on auto lines that work great for $5,000 or $6,000, literally. And so we do a lot of refurbishment of automation on our own instead of buying these newer solutions, and the return on capital is just phenomenal. So that's a challenge, I think, when you start looking at all new solutions. It's often hard to get a good return.
Yeah. What is success? What is success? Is it 10% improvement year over year? You can't measure more than a minor percent, maybe month over month. But what is success over the long term? Is it 10% over 5 years?
Well, I mean, I think the first question, as you note, you really have to ask is what's your time scale, right? And one of the big problems we have in the country here is we have a private equity driven mindset, generally speaking, which is, and it's not that every company's private equity owned, but they set the market, which is
take the cost out.
We're going to buy a business, I'm going to drive profits up in 3 years, and then I'm selling it. And so that means your time horizon is actually 18 months.
Right.
You have to put stuff in, it has to start showing a benefit in 18 months so that you have it in your books to show in the sale. We are a permanently capitalized business, and so we are looking for things that are going to provide a return in 5 or 10 years. So we have a very long-term horizon. So the amount of return that we need in any given year is pretty modest, and that lets us be a lot more aggressive with investment, but including, again, I want to return to investment in people as much or more than in what we call tombstones, right? Big pieces of equipment that it might turn out you don't need later. People are very flexible. They're the best kind of automation in the world, and what we want to do is use tools, digital or otherwise, that augment people.
Right. You make a great point though, in sort of the private equity mindset, and to date, manufacturing and production has been driven by private equity, partly it's large established industries where honestly, you look at them and say, we can take a lot of cost out. I mean, you can just look at the past 2 years of this inflationary environment that we're in, and manufacturing is actually down, partly because it was exploding in the pandemic, but it is down year over year. And so again, there's this mentality of taking costs out versus driving more revenue through some of these processes.
Now, don't get me wrong, we try to take cost out, but we do it in a way that we think is more sustainable.
Right.
A lot of this sort of, high pressure near-term cost out is what destroyed the whole US industrial base in the first place. It hollowed it out and it could not compete in the next cycle.
Yeah, there was a time, coming back to Yvonne here, there was recessionary periods going through the 1960s where as the country recovered from them, up until the 60s or maybe the 50s, jobs growth continued in manufacturing. But around that time, it became more of like, oh, we took some cost out. Oh, we can take more cost out. We'll just keep taking cost out.
Or let's offshore the whole thing.
The economic, even after the economic recovery happens. So how do you think about, but we are at this critical point of like new technology actually not only being able to take cost out, but actually being able to revitalize revenue and like new opportunities and digitizing or AI generating, whatever the new term is. How do you think about that?
I think the thing that we're trying to focus on, number one, is we're going where the growth is. And we already are very lucky that we are in industries that are fundamentally still going to grow and where we have so much upside ahead. Things like, areas like fighting climate. That is where at the very nascent stages, this is the existential threat in the planet, and there's so many different startups here that are all finding different ways, and most of them have a manufacturing component. So that is still a ton of growth. In life sciences, we are the world's epicenter there. Life sciences continue to grow. Whether the economy's up or down, people are sick and they need to get healthier, and we still have so many more discoveries ahead around cell and gene therapy, and so many more opportunities to do manufacturing here in the state. And in defense, in the defense space, we have a whole federal government saying we want to bring more advanced defense technologies back to the U.S. for national security reasons. And so there's a huge opportunity for us. We already have a lot of defense footprint with MITRE and Lincoln Labs and all of our universities and all of our companies. How do we actually do more on that front here? Again, there's a big manufacturing component to it. So I think we're very lucky here in our state that we're playing in industries that are solving big problems for the world that are going to continue to grow. And then within that, we're trying to make sure that we have all types of jobs. And so this idea is, how do we have great training for people who don't want to go to college to become really skilled quality engineers, kind of analytics folks, lab techs, that are, great career paths in these high growth fields that don't require college degrees, but are on the manufacturing, footprint.
Yeah. And John, you and I were talking before the panel about how one of the big things that MIT is declaring that climate is such a big focus. And Yvonne's mentioned it a couple times. Certainly manufacturing is big in climate as well as biotech, probably some of the bigger sectors, advanced materials, the mechanical side of it. How can you give us a sense of the day-to-day and the focus on climate at MIT?
Yeah, well, everyone at MIT is excited and eager to make impact in the climate space. Our President Sally Kornbluth, who joined at the start of the year, has declared climate as her priority, and we want to help, not just in the way of doing the early stage research in our labs and publishing papers, but field technology and understand the implementation and the behavior dynamics and all those things. So it's great that we're here in Massachusetts, and we also have the materials and manufacturing technologies and the support from the state leadership to think about like building the institutional capacity. And back to kind of an earlier point, I feel our biggest gap in our curriculum at MIT and how we train our students is on the operations side, actually teaching them how to lead and how to run organizations and grow manufacturing operations, not just the technology pieces and the AI tools and so on. So I hope we can enrich our curriculum and partner not just for the manufacturing workforce, you could say, but for the leaders of these companies that need to grow and need to go fast, because we need to move as fast as we possibly can to make the impact that's needed.
And the other thing I was going to say is that, so we have these big growth industries, but also we are a leader in robotics. We have an amazing nonprofit, Tom from Mass Robotics, and our Mass Tech team, and we can lead in manufacturing the robots that go into these advanced manufacturing sites. And so the actual manufacturing of the robots is another big opportunity for our state, where we're already doing a lot of it here, and it's a high growth area because there's still so much more opportunity to automate and to use robotics. So that itself is a new industry.
It is a huge, this area, just Boston, Massachusetts more broadly, to walk in this morning and see not just Autodesk, Tulip, Formlabs, but Stratasys, Desktop Metal, just a number of different companies, all PTC, Onshape, all of these guys just around in one room, and you have such a brain trust of people to learn from in this area. But you were going to say something about climate.
I was going to add, I don't want to be the Luddite here, but I think I'm becoming that. But The real challenge we have in clean tech or any of these new big technology fields, and we do a lot of work in clean tech, we do a ton of work in hydrogen and other areas like that, is that it's not the technology that we've been talking about here today, which is, I think, largely over-the-top technology. It's the fundamental stuff, like where are the foundries to make stuff, right? Like we do a lot of work with Commonwealth Fusion. Like where are we going to get the superconducting wire? Like where is it? We don't make any of that stuff anymore here.
Right.
So I think a lot of our technology investment needs to be more fundamental than like over-the-top digital tools. We need to make the basic stuff. We stopped doing that. We handed that all over to China, and it's a real national security threat today and a real danger to our way of life, and like that's where we've got to focus. And it's great to focus on tools that will make stuff run better, but if we're not making the stuff in the first place, that's not going to be that helpful.
It has to be foundational. It has to be like, not these bolt-on, like you said. And
right.
You see security, you see a number of things that are, even in the IT world, that have been bolted on, and you need from the fundamentals. And it goes back to the 50s and 60s where we just stopped.
We let it all go. But like, I get it, it's great to have work instructions tools, right? But if we don't have gear shaping equipment to make gears that can go into new robotics, then I don't need any of that, do I?
Right, right.
Yeah, I would say, having seen a couple startups scale over the past several years, I think that's one of the biggest challenges. Like, how do you find the Legos, if you will, to create your machine or to build your factory, and the pain you go through when you're on a tight timeline to meet your milestones, and maybe there's a way we can encourage more of that entrepreneurship among new small and medium businesses. It doesn't need to be everyone starting a new high-tech company. It can be just appreciating what's needed to build an ecosystem, build a supply chain where there's opportunity for growth and stability to support these emerging industries.
Yeah, and Yvonne, you were talking about like the biotech industry, for example. We have a business that develops all kinds of innovative consumables and devices for RNA and DNA-based therapies, right?
Yeah.
But it turns out 99% of the consumables for that end up being made in China, because it turns out the technology to make really flat microchannels is the same as making the back of an iPhone flat. And we let all that go. And so we're spending our time, when we talk about digital technology in general, is how do we rebuild that infrastructure? Because I appreciate that it's great that we might be designing a lot of that stuff in Massachusetts, but most of the jobs and actually most of the revenue in the net is running out of a plant in Shenzhen somewhere.
Well, that's why we're excited about the Biden administration, and you're in DC, so you know there's $250 billion that the federal government is giving to companies and to states to try to bring that back. I mean, so the statistics are staggering. When you look at semiconductor manufacturing, for example, a couple decades ago, a big chunk of that was invented in the US, made in the US, and that's now all mostly gone to Asia. How do we now bring that back? It's early days, and we're competing along with lots of other states, and we're supporting all of our companies to try to make sure that we do our part to bring that technology and some of this value chain back to the US.
Yeah, though again, my concern, we try to engage a lot with the federal government and state governments, and a lot of the energy is going to the end point. Like we're going to produce cells, right? So we're going to stand up gigawatt factories to make cells. But what we're not doing is working back behind all the tons of infrastructure, machinery, equipment, technology that is behind that on a fundamental level. We either do two things. We focus on the end point, or we're going to invest in heavy technical research on new battery cell chemistry, for example, but then we can't make it. Right? It ends up being piloted in China, and then it's very hard to get back. So what's lacking is money for the guys that are going to develop, and gals that are going to develop machine tools, fundamental process technology to support all these industries. But that problem is that doesn't work on political time. That's like a 10-year arc. Like we can't do that in 2 or 3 years. It's just not doable.
And that's where, if we can square the step change functions of new technology with some of those fundamental, advancements, then that's where it should be perhaps directed. We're seeing more and more on the materials side. There are startups out of MIT focused on, cement and sustainable processes there that are very fundamental. But yeah, it has to start. That's a great insight. Yeah, it has to start at the core.
And many of those processes are really awesome and exciting and ripe for technological improvement,
100%.
like using data to overlay a metal forming process and improve the productivity 10-20%. And there's cases where the aviation and defense supply chain is almost breaking because of high demand, where these analytics being deployed on the factory floor are enabling higher productivity and improving the pace of that existing infrastructure. So I think we also have to look for those kinds of applications.
And it is a great opportunity for Massachusetts, because when you think about even some of the incentives that the federal government has now, with the IRA as well as the CHIPS Act and whatnot, standing up new facilities in different states, you wake up and you're like, but the talent's not here. The talent to actually implement them is not in the physical vicinity.
Well, and the other thing is that having run a lot of operations myself, it's a pain to have to get on the plane and fly to China and have different time zones and different language and all kinds of miscommunications. It's so much easier to drive to Central Mass or to Western Mass, way cheaper, way more land, but still skilled labor, and you're in the same time zone, in the same state, and if you have an issue, you can all be on the same team. You don't get this kind of miscommunication where it's your fault or my fault. You kind of all work together, and we did that when we were at PillPack, and I think there's a really hard to quantify, but a huge benefit for, especially when you're starting to scale and working on new innovations, of having that kind of teamwork as you deploy and scale manufacturing.
You did mention I'm in the DC area, and I know you spent a lot of time in DC too, and there is a realization of just short supply, way behind on technology, that just in the past 2 years since the Ukrainian crisis, frankly, that they've woken up and said, wow, this is actually severe, because now there's more demand for what we have and we don't have it. How do you think about, in any of your sectors, including Massachusetts, but how do you think about the defense space and what you're doing, or do you not?
Sorry, I didn't catch the back.
How do you think about the defense industry and what you're doing, or do you not?
Well, yeah, no, it's like a quarter of our business. So we do
Okay.
a lot of commercial and defense-related aerospace, particularly drone development, eVTOL, all of that, right? So those are areas that in some respect we've been fortunate as a country, because whether it's composites or certain technologies, we sort of intentionally maintain that. But there's huge room for efficiency and improvements there. And that's actually an area where I think this sort of digital layer can make a big difference and needs to come in sooner than later. The trick is, of course, that you have a lot of old school programs, right? Large dollar, like F-35 planes, right? Very slow monolithic production. And we need to make this transition very rapidly to much lower cost, higher volume product, like
attributable,
right? Drones
yeah.
that cost $1 million a piece, and we can make 35 or 50 of them for the cost of one fighter, right? So that's where digital technology, I think, has a huge potential impact, and you're starting to see that. Anduril, companies like that are really like redefining that. There's Kratos, others. We work with a lot of those companies, and that's, I think, an area that's pretty interesting, and we have to become more dynamic, frankly, in that area.
Has that cropped up at MIT as being a more interesting space to the talent coming out than university
definitely.
level?
Of course, we do a lot of DoD-funded research on campus. We don't do stuff that's sort of DoD confidential or ITAR restricted, to use the acronyms. A lot of that is done at MIT Lincoln Lab, which is a federally funded research center. But of course, our mission is to do basic research that has broad application, including in the defense space. And to Miles' point, I find the Andurils and the companies that are developing new products rapidly and showing that model of more rapid innovation and need identification to be exciting and attracting the young talent who might have instead gone to Apple or Tesla or so on.
Mm-hmm. Yeah.
And I hope we have more of those such companies, and the whole supply chain, from small businesses to big companies, in that area, both in Massachusetts and nationwide.
So how are you guys thinking about at the state level of how to embrace the federal spending, how to tactically take advantage of it? You have the Mass Tech Talent Initiative, but sort of both of those acts in particular.
So we've been very, very focused in this Healy Driscoll administration on coordinating with all of the companies and all the academics and all the nonprofits to really play. I have my bracelet, my Team Massachusetts bracelet, to play together as a team to go after federal opportunities. So we have been very coordinated. Mass Tech has taken point on all of the chips and science opportunities, and the $250 billion is coming out in little tiny different grants from DoD or Commerce or NSF, and so we're coordinating and trying to be supportive on all of those different opportunities, and we've been actively bidding. We've won some already, which is really exciting. And then in life sciences, there's also ARPA-H, which is a really ambitious kind of, how do we go after the moonshots and cure big diseases that are out there. We've been also coordinating as Team Massachusetts to go compete on that, as well as IRA. Lots of opportunities there around infrastructure and climate. So we're coordinating across cabinet, and actually we added a senior member of the team who came from DC, from Commerce, to help us focus on federal opportunities. And we have a guy in DC, actually, who's working on the ground to make sure that we understand all the dynamics. So this is a big focus of our administration, to make sure our state does our part to help solve these big problems for the country.
Okay.
Interesting times.
Yes, definitely interesting times. And I want to think of just a a parting thought for each of you. To the practitioners in the room, we also have startups and entrepreneurs in the room. We've talked about climate, we've talked about life sciences, we've talked about challenges with workforce development, as well as challenges with automation and what your expectations should be. For somebody in the room, mostly the practitioners, thinking about where to focus and if they had limited resources, which we all do, is it on automation? Is it on new markets? Is it on workforce development? How would you allocate your time and attention?
You're looking at me?
I'm looking at you first, because you are allocating your time
I
and
think
attention.
I just reiterate what I said earlier. I think technology is super important. We as a country are really good at that. We should take advantage of it. We should make sure that it's always done in a way that indicates a respect for people and is done in a way that's people-centric, and that means not just management, but all the way through the company, and that's the best way to get the most leverage out of an organization to be competitive over the long term.
Yeah, I'd say it's talent development, and it's also getting out in the world, identifying needs, problems, and bringing them into the academy and helping develop solutions collaboratively.
Yeah, I mean, I don't know if I have a lot of advice, but I actually do have an invitation or maybe a challenge, which is that I feel so lucky that we have all of these smart brains and all of these super committed people working on these innovative technologies. And I would love to have you be on Team Massachusetts. So if you're here already, thank you. If you're not here, come join the team. But I really would love to invite you all to let us know what can we do as a state to help you and to support you and to partner with you to be more successful, to accelerate these inventions and to scale them up more effectively. And so if you have ideas or feedback or things we could be doing better, we would love to know, and we'd love to partner with you.
Amazing. Thank you all, and a lot of topics we covered. Thank you all.
Thank you.
For sharing your thoughts.
Yay, thanks. Thanks, Dayna.